So basically, I must say that, guys, you are lucky because this morning, Riccardo and Harry, and this afternoon, you have been into the school with a great presentation of the basics of what is remote sensing, what is mapping. Marco and Angelo said a lot about what is behind the maps, what is the world around mapping. And now, this afternoon, we go a bit technical and we see what is behind them. And what's behind all this mapping world is what you will be using to produce your own map at the end of the school, hopefully. So we are speaking about GIS. GIS is kind of common now in planetary, but it wasn't 20 years ago. So GIS stands for Geographic Information System, and it's all the bunch of technology and procedures and softwares and also skills that enables to gather the geographic information together and analyze it. What does this mean? Basically, that we are able with GIS to associate some geographic object with the non-graphical object, with some kind of non-graphical information, which is usually hosted in database. So the information within GIS is stored as a layer. It's used to. There is a jargon that you will be using these days, and layers is the hot word. Layers keeps keeps the information separated, but also allows to overlay information. So GIS has been developed in the early 80s of the last century to manage environmental data, basically. So, for example, these pictures is very clear because it explains how GIS overlays different kind of information. In the case of the Earth, for example, we have street data, which is stored in its own database, if you will, in its own storage. Then you have information about buildings that can come, for example, from another database in another office. And then you have vegetation that can come from an institute for environmental research, for example. GIS allows to gather all this data together, to co-register the information, to integrate them within a single database. And at this point, we can do analysis, because having this data in layers is not enough, or well, is not interesting enough. The good thing is that layering this data together starts to be intriguing when you can do something with this in terms of geospatial processing. Geospatial processing is the act of processing data where data is geospatial, has some location-based characteristic. And if you think, basically the 99% of the information that we saw seen this morning is geospatially located. So everything that have been shown by Riccardo is geospatially related. And just think all the slides or of the really good lessons from Henry. Just think about all the information that had been discussed in the different slides. It would be very cool to stack them together and then have it in a single integrated database, which is the goal of the GIS, and that is the reason why in the last 15 years GIS has been using has been used also in planetary science, and now is kind of commonly used. So for this reason, we are introducing QGIS, which is one of the GIS system, desktop GIS system used in among the planetary scientists. And this is the logo that characterized QGIS. And QGIS is kind of peculiar because it is a part of what is so called, because it's a very modern way of saying it's an ecosystem, or well, it's part of a bigger group of softwares which deals with the geospatial data. And basically, all these logos are part of this OSGeo, which is a foundation organization, and they are specialized in different kind of geographic or geospatial data analysis. For example, we have, of course, QGIS, you have the Postgres. So if you are into kind of planetary science, for sure you should have heard about Postgres, maybe more on the engineering side. If you're more on the scientific side, maybe you have heard about GDAL. GDAL is the Geographic Data Analysis Library. We will see that afterwards. Something that is not very common because it's kind of more difficult to use is GrassGIS, which has been the pioneer of free open source software for geographic information system, but not only because it was developed in the 80s by the US Army Corps of Engineers, so it's very mature. Let's say that it's the grandpa of the GIS in here. Then you have, for example, the tools for projecting. When Angelo said that projection is important and projection of the reference system of the planetary data is critical, the project is our friends to deal with this kind of problems. And then we have some other projects. The OSGeo project is the umbrella which collects all these projects together. So QGIS, where does this software comes from? QGIS was born in the early 2000s as Quantum GIS. And in 2007 becomes part of this OSGeo Foundation big umbrella, which basically holds different projects together. And in 2009 becomes 1.0, which means in terms of maturity, it means that it starts to be mature to be used. And in 2013, the official name of QGIS becomes not Quantum GIS anymore, but the QGIS. And in the last 2 years, we have the version 3.x, which is a big update, especially in the part of the rendering. So since version 3.x, we have the chance to use symbologies and to have a graphical output which started to be usable, for example, in geologic mapping, and so also planetary geologic mapping. And down here you see also the evolution of the logo of QGIS. So of course it is a Q, and since the beginning the Q becomes this logo that you see today. The technical aspects of QGIS are listed here, so we will go through that because they are kind of important for understanding what is behind QGIS. So basically QGIS has been developed because it was needed at that time. So in early 2000, it was necessary to have a graphical user interface to the geographical information in the free open source software. That was the need. So basically, we need something to play with in a graphical user interface, and something that was visually pleasant to see, but also usable. And for example, mapping needs a graphical user interface to be carried out. The good thing of Qgis is that it runs on Linux, on Windows, on a Mac, for example, but also on Android. So it's very portable, it's said. So you don't have to have just one of them. You can run the GIS in every operating on the most common operating system abroad. The messages, or well, the menus and the graphical user interface text is translated in 48 languages, which make it very usable for the didactic, for example, for teaching GIS. A very important point is that the data I/O, it means input and output, is managed through this geographic data abstraction library. And this is very important because the GDAL, if you are in planetary science, it will be your Swiss Army tool for dealing with data when you have to do processing of your data, for example, for your PhD or whatever. It is QGIS is being developed on GitHub in a collaborative way. More on that later. And basically, people who contribute to the code release updated, but also works on fixing bugs, which is very important. And we will see that planetary science needs to enter this kind of perspective to improve the software that we are using. Another aspect which is important for us, because today we will see that there is a plugin that will help us to do our maps, is that there is a mechanism where you can contribute to QGIS with the so-called plugin, which are extension of the basic functionalities. And nowadays we have more than 600 plugins. So every kind of specialized functionalities have been developed by the single person that they needed, and they put together, and they put into a kind of, and they share this plugin with other users. So from Wikipedia, you can see about this some of the story about QGIS is starting to be used by national agencies. You see a list here, and it means that it starts to be a mature project, and the contribution starts to be also bring in by national agencies. So what is the price of QGIS? Before this school, you have received an email that says that you can download the latest version of QGIS. But how does it work? You can download a software for free, and what is important is that you have downloaded the latest version with full functionalities. So how does this work? Does it make sense? Because if you don't pay for something, what is the value behind that? So this needs a kind of explanation. So basically, QGIS is a free open source software, and the characteristic is that these free open source softwares, they have a licensing system, and which enable a multi-sponsorship of the project. So basically, we are downloading QGIS for free, but the cost of the software is paid by someone else, let's say like that. So how can this work? It works through a kind of trick it's not a trick, but when you download the software, or when you, for example, you subscribe a service on the net or a social network, you sign a license, which is a contract basically, which regulates what can be done and what can't with that software. In the case of QGIS, when you download the software and you open the software, you accept 4 points of the licensing system. And so this is important to know, because if you will keep using QGIS after the school, you should be aware of what you can and what you can do with the software, of course. So with QGIS, you are free to run QGIS or any other free open source software similar to Q. So for example, the Linux operating system works like that. So you are free to run the software in all its functionalities. So you are not limited. The QGIS you download is the same one that, for example, Riccardo uses for his work, or me I'm using, or Angelo is using. So you are not downloading a demo or a limited functionalities version. You are downloading the fully functional QGIS version. And you can use it for any purposes. So you can use it for research, but also for commercial. You can use it for any purpose you want to. The second point is that you are free to study how the software works. What does this mean? This means that if you are willing, you can disassemble QGIS and make your own QGIS by programming, by changing the code. And this is legal. You can do that. And to do that, this implies that QGIS comes with your software that you have downloaded, but also there is the source code, which means that on the internet, you can find also the list of commands that makes the software that makes the software working. The third point is that you are free to copy and distribute copies of the software. And this turns useful for our school. So this winter school works because also we were able to copy all the QGIS and distribute the copies of QGIS to every participant, which is important to follow and to produce maps by ourselves during the school, but also after the school. So it's kind of a very important point. The fourth point is that you can redistribute modified version of the software. So if someone of you is smart enough, can produce its own QGIS version and redistribute the software under the same terms he has received it. So these 4 points are kind of common among the free open source softwares, and are kind of enabling something which is this kind of graph. So with this 4 points, you are free also to decide what kind of level of interaction you have with the software. So I explain better that with free open source software like QGIS, let's say the only thing I can say to you about this software is that you will never end learning about QGIS, because you have free access to all the kind of information from the interface of QGIS, but also how it works internally. So you can choose during your career to be a casual user or kind of everyday users, a power user, which means a user that finds very elegant solution for a problem. At one point, maybe you can contribute to the project with your own ideas, or by producing documentation or fixing problems in the software, or you can develop the software by yourself. And this is interesting, because if we are a researcher, we are user, but as a researcher, you will often find limits in the software, and you are willing to overcome these limits. And this kind of system is ideal for a research environment. So, as I said, QGIS comes for free, but there are costs. And if you want to give back, or if you are just willing to know how to give back, there are some ways that I listed here, and they are very simple. The first point is obvious. You can contribute with donations. Donations can be like €1, 10 euros, but companies that start to work with QGIS may invest more than that. For example, QGIS has developed a membership mechanism which allows to big companies or big society or big agency to be a member of the QGIS kind of consortium, so they can contribute with big amount of money. But if you are a student, for example, you can contribute with time. With, for example, Luca, who developed the Mappy plugin, basically contribute to QGIS with its own time. So it's not money, but time can be really precious. And so the time of Luca is transferred to all of us, that we will do basically the mapping with this plugin. So that is also a kind of way of contributing to the project. If you find some problem and you are able to describe it, it's also valuable, because someone can fix it, but you have to be very good in describing the problem. So that is also time. Translating documentation, as you see, the interface is translated in 48 languages, which is a lot. And that 48 language has been developed translated by single users. So going into the practical side of this free open source software, I want to give you a practical example on how this mechanism works, and it has been working for planetary data in the last 10 years. The GDAL, which is the critical part of this GIS system, so it is the library. So it is a piece of software that allows to import and export data. It means that allows QGIS to speak to the other, to the archives or to the journals where you produce the maps. So in case of GDAL, since GDAL is also a free open source software, it was possible in the last 10 years to have contribution from different people and different institutions from different countries and continents, if you want. It was intercontinental in this case. So first, there was Trentair from USGS Astro, who has the idea to support GDAL by introducing the ability to import PDS data directly into GIS. That means that all the planetary data system that you will for sure meet before and after during your career can be imported directly into GIS thanks to a contribution of USGS, which sponsored the development of that part of code, which became part of GDAL about 10 years ago. And now every one of us can use GDAL to open directly PDS data. The same comes from Sebastian Walter, for example, at the Freie Universität in Berlin, who contributed with the access to VCAR. That at that time it was critical to open HRSC, if I remember well. And so at that point, the contribution of Sebastian and Trent and USGS Astro gathered together into GDAL, which was able to open PDS data and also the VCAR HRSC. And then in the last years, we had also the implementation of these GeoFits, which allows to open into the GIS the FITS format, which is a format which is not common in GIS, but is very common in the astrophysics environment, which has been developed by Chiara Marmo at the University of Paris Sud. So this is an example on how this mechanism of licensing works and how this software grows thanks to the contribution of several people. So the message is that we got them from free, but we have to be careful because we have to maintain them and to contribute them to basically to give back to them to what we receive for free. So in case of QGIS, we have this multi-sponsorship model, which is kind of interesting. I want to show you because it's important. Also, it's visually appealing. So if you see, this is the qgis.org website. You see a list of sustaining members. So those are people that are paying basically money to QGIS. The membership level is the level of contribution to QGIS. Let's say that large is like 20K, 20,000 euros. So the fact that the license says that we can contribute to the development of these, it means that the QGIS user group Denmark can contribute, a company can contribute, another company, and then we see small companies, some user group. So user groups are basically normal people gathering together for learning. And then this is the history. And if you can see, the history of contributing members is very long. It's extremely long because basically everyone wants to contribute somehow, even if it is nothing or few, even if it is just few euros. You see that the number of people around the support system is big. So that is the idea, the fact that the licensing system allows to contribute to the development at different levels. So are there questions about this introductory stuff about QGIS? I know that is not so. We still didn't speak about planetary, but it was important. I think it's important to know how the mechanism of development works. Let me see in the chat. Maybe Ricardo, check if there are some questions, please.
question is if you are going to implement GDAL during class.
Unfortunately, no, but we can point out there is some tutorial around about GDAL and planetary, and maybe we can point out that there should be an open planetary talk by Trenter, which is the wizard of that.
Okay. Then there were other discussions about different kind of software, and but I think they were even fulfilled by Riccardo and Angelo.
Mm. Okay.
So I think that you can go on with the practical now that you have introduced the Qgis system.
Okay, so let's come to our business though. So let's start from the end. Let's say, okay, this is the end of the story of QGIS in planetary. So free open source software in planetary comes to this kind of figure. So this is the geologic map, or well, a geologic sketch, which has been published in a peer-reviewed paper, and it is a geologic map of a quadrangle of Ceres, and it has been produced completely in QGIS 3 point something, and this means that at that point we have a tool that allows to start mapping and producing a meaningful geologic map, and to dress this map ready for at least a peer-reviewed publication. So this work has been published on Icarus 2 years from now, and so this is just a demonstration that it can be done, and we are there to do that. So so these days you have downloaded the QGIS, if I'm right, and some of you maybe are more expert and some of you are less expert. So I just give you a brief introduction, but Riccardo is coming with some practical, more practical aspect. But I give you an introduction on how does this QGIS look. So basically, we have the graphical user interface, GUI, which is divided in several windows or dock. In the top, we have the tools or the icons, which replicates the functionalities of the menu, which is on top of your interface. Then you have a kind of data browser on the left, and the data browser is the place where you can locate the data and the services. You will see that there are services which are very useful for us, which allows to get the data into the GIS without having to download without having to download the files directly. Then we have the place where we have the stack of layers, that where we can make order of our information in a layered way. And then we have the main window which when you start contains all the news and the project templates, which will be useful when you will use QGIS day by day. And then there is this bottom bar, which is very important because as mappers, we will take a look to the scale, the coordinate, and also the magnification to explore, to investigate the detail, to examine the details. And then we have also the coordinate reference system, which is being used in the map. So which kind of information is going to be ingested into GIS? The people that uses GIS, maybe the first lesson. So the lesson 1 of GIS is the different data model of this geographical information. So for those of you who never saw the raster, these different data model, I give you a brief overview of that. And the next days you will work with this data. But it's important to know that they exist and how do they work. So we have basically 2 different data models, and they are completely different, but they are 2. So it's easy. So the raster data model is the one that allocate the information in a continuous way. So you have a matrix of information. So the raster data model is very easy to understand for the physicists, for example, because they are used to metrics. So you have the information which is ordered in rows and columns or sample and lines, and it covers all the study area, the area you're studying. So it's useful for continuous information. There is a new vector. There is a new model for the physicists. Is kind of more difficult because it's not very used in, for example, in what is called is IDL, NV, or whatever, and it's the vector data model. The vector data model is interesting because it is a very smart way to represent linear features, areas, which otherwise should waste a lot of memory, let's say, for the geeks. So the vector data model, it's the second data model, and it's important to consider this vector data model because geologic maps in GIS are vector now. So every time we see the real world, in this case, the real world is the Earth because there is a lake, there are the pines, and there is some grass here. And so the real world can be seen with the eyes of the GIS expert as vector or raster, and you will be the one that decide which data is better to import in which model. Okay? So, but what is this raster and vector data? You saw the raster and vector data all the day today. All the day it was a continuous information about raster and vector, raster and vector. Maybe you didn't know that was raster and vector. So this is an image which I asked Ricardo to give me. It comes from this morning presentation. And on the left, you see the volcano. You remember the very cool example where the volcano has got some lava flow in a glacial environment. So you have carving of the flank of the volcano, and then the lava that was accumulated here into the oblique crater and whatever. And so all these feature that has been detected by the remote sensing process that Ricardo told us this morning can be encoded into a vector map, which is the one that you see on the right, which is superposed on the raster data. So on the left, you see a typical raster information, the image, the base map. The base map, this imagery base map, is a raster image because it covers all the domain you are studying, while the geologic map, or well, the geologic units represented over the raster data, so we are doing GIS, we are speaking GIS, is represented by these polygons. If you see, the color are basically the areas filled by colors. And so this is vector information. And this is, it's simply a different way of representing a model of, in this case, of the geology, and is particularly efficient. And we will see why we are using vector data. Okay, at this point, I will leave the stage to Riccardo, which will tell you more about using data within QGIS. And then we will see later on, we will see how to install plugins and how to prepare QGIS for planetary mapping. So Riccardo, the stage is yours.
Thank you, Alessandro, for your presentation.
I don't know, Riccardo, if we can take 5 minutes of rest, since
that's
we have
what I
no
was
rest
saying
from the beginning. Okay. So we can.
Also, if there are questions from the
if
guy.
there are, yes, we can collect questions. If you have questions, please ask. We can stay 10 minutes from now before starting again with Riccardo. Actually, there are no questions at the moment, so we will stay here in any case 10 minutes. All the other can take a rest, and we can reconvene at 3 and 40 past 3. Actually, there were a lot of questions, but they were fulfilled by Angelo or Riccardo.
Nice.
Okay, you can see if there are something that was. So there were some questions about the use of Saga.
Okay, I was muted. The use of Saga GIS. Who is using Saga GIS?
No, there were one questions if someone is using it for LiDAR images, and but they want to know a little bit more about this.
Yeah, the good point of QGIS is that since it is a graphical user interface, since the beginning, it became a graphical user interface for the free open source software like GRASS, for example, who didn't have, let's say, a modern graphical user interface. That's not true, but of course, it was not aimed to the graphical user interface. So long story short, you can use Saga the Saga GIS can be used directly into QGIS. You see the screen, right?
Yes.
Yeah.
Okay, if you see on the right, now I have fire up the QGIS, and on the right, on the processing toolbox, you see that you can use all the Saga GIS which comes as module within QGIS. So basically, QGIS is bringing in Saga within its own interface. So it's not a special version of Saga. It is Saga GIS. And okay, so Riccardo will show that. So perfect.